Introduction to the Flutter frontend now. We move to the phone side of things. We chose Flutter because it allows you to write one piece of code that runs on both iPhones and Androids. Flutter uses a language called Dart, state management. In the code, you see a class called stateful widget. This is a crucial concept in mobile development. A state is simply a memory of what is happening in the app right now. For example, if the user has picked a photo, the app needs to remember that photo's location so it can display it or send it. When we use the command setState, we are telling Flutter something has changed. Please redraw the screen so the user can see the new information. Without this, you might pick a photo, but the screen would never update to show that it was successfully selected. The image picker and user permissions, modern phones are very protective of user privacy. You cannot simply reach into a user's gallery and grab a photo. The image picker library we included handles all the legal work with the operating system. When the pick image function is called, the app pauses and asks the phone's operating system to open the gallery. Once the user taps a photo, the operating system gives our app a path, a map showing where that file lives in the phone's memory. We store this path in a variable called selected image, the multi-part request. Logic. This is perhaps the most technical part of the mobile app. To send data to the Python server, we use a multi-part request. Imagine you are sending a physical package through the mail. Inside the box, you have a letter, the text, and a physical photograph, the image file. A multi-part request is the digital version of that box. It allows us to mix different types of data, plain text and binary image data, into one single delivery. In the code, we use a double dot notation, which is a shortcut in Dart. It allows us to add the text fields and the file fields to the request, one after another, very cleanly. Once the box is packed, we use the send command. This pushes the data out of the phone's antenna, through the Wi-Fi router, and into your computer, connecting the two worlds via local IP. One of the most common points of failure for beginners is the connection between the phone and the computer. In the code, I used a placeholder address like 192.168.1.x. Every device on your Wi-Fi has a unique ID called a local IP address. To make this app work, you have to find your computer's IP address and type it into the Flutter code. This ensures the phone knows exactly which house on the network to send the data to. The user interface layout. The build method in our Flutter code defines how the app actually looks. We use a scaffold, which provides the basic structure like the top bar and the white background. Inside the scaffold, we use a column. In Flutter, a column stacks items on top of each other vertically. First, we have a text field where the user types their message. Below that, we have a button for picking the image. Finally, at the bottom, we have the Generate button. We use sized box components to add invisible breathing room between these items. This makes the app feel professional rather than having all the buttons squashed together at the top of the screen. Future enhancements and error handling. The code we wrote is a minimum viable product. It proves the connection works. However, in a real-world app, you would want to add a few more things. The loading spinner. Right now, when you hit Generate, nothing happens on the screen while the data is sending. In a polished version, you would add a circular progress indicator. This tells the user, hang on, I'm working on it, the video download. Once the Python server finishes making the video, it currently just prints a message. To complete the loop, the Python server needs to host the finished video file, and the Flutter app needs to use a video player package to stream that file back to the user's screen. Error messages. What if the Wi-Fi is turned off? What if the computer is asleep? We use if statements to check the status code of the response. A status code of 200 means everything is great. Anything else means there was a problem, and we should show a message to the user saying, check your connection. Conclusion for the TTS reader. By combining a Python fastapi backend with a Flutter mobile frontend, you have created a powerful system that bridges the gap between high-performance computing and mobile convenience. Your Python logic stays where it is happiest, on a powerful machine, while your mobile app provides a simple, elegant way for anyone to interact with your creation. The flow is simple: pick, type, send, process. This architecture is how almost every major app you use daily, from Instagram to YouTube, functions under the hood.